gyroscope that we use for our circuit is the IMU digital combo board. It is actually a combination of a gyroscope and accelerometer. A gyroscope measures rotation but cannot measure orientation, while an accelerometer detects orientation but is unable to keep track of movement or rotation. By combining these two components, the gyro can kick in when the accelerometer leaves off, and vice versa. This makes the components more efficient and effective. Both of these components communicate over I2C, which is a two-wire serial connection that makes it simpler to connect to the Arduino.
Sensor. It's a device to monitor the heart rate. The dimensions are 0.65 inches diameter and 0.125 thick. The pulse sensor amp is a plug-and-play heart rate sensor for the Arduino. It's a combination of an optical heart rate sensor with amplification and noise cancellation circuitry, making it fast and easy to get reliable pulse readings. Assist power with just 4 milliamp current draw at 5 volts, so it's great for mobile applications. The RFL link transmitter, dimension of 2.5 centimeters by 1.1 centimeters, works well with microcontrollers to create a very simple wireless data link. It's used to generate and transmit electromagnetic waves carrying messages or signals. Since you don't need a receiver, the transmitter communicates one way.
Okay, hey guys, it's Amir again, and I'm just going to take you guys through the schematics and also the application that I made that will process the data and then give the user a nice fancy user interface that they can look at the data on. So here's the schematic, and basically what I did is I used this software called EagleCAD, and it's a lot like Multisim, where you can just go, you can add parts, and so these were pre-made sketches that I actually got through the SparkFun website, and basically I just organized them onto one board. And the key feature here is that these tags, right over here, these tags correspond to the tags with the same name would be connected. And so the interesting thing I found out about this EagleCAD software is that you can actually order parts from it, design your board, and then order parts, and they'll actually build the board for you. They'll build it how you want it and then send it to you. And so if we were to build our board, this would be like the ideal board for our whole project, incorporating everything together. However, we pre-bought everything and just put it together, as I'll show you guys later. Okay, so now I'd like to do a quick demo of our application in real time. I originally had pictures, but I figured it'd be better to show you guys it. So unfortunately, due to some technical issues, I can't show you guys the application on a phone, like working. But what I have here is an Android emulator, which I built the application on, and I'll just demo it on here for you guys. So basically, here we have our Android home screen, and if we open, it's here the heart rate monitor app, and right here, so this is the home page. It's pretty simple. You can enter your name. I'll enter in Amir, and then we'll do like my doctor. So here you can put in your doctor's name and your email. So later in the application, I'll show you where that functionality kicks in. press enter, and it says you have successfully made a profile. That data all goes into the application. And then, so here, this is for further functionality. I don't have this built in yet, but I thought it'd be cool if you could just tell the app what level of activity you're going to be doing, so it could gauge that into the heart rate. That way you would have less noise, less like variable heart rates as we do now. But right here, I'll just open the heart rate tab to just show you the bulk of the project. And once it's connected, it's not connected right now. Right now it's just going to show you random numbers that I've set through a range of normal heart rates. But if we press get heart rate, it'll generate a heart rate, and then if we click on list right here, it'll actually compile all those heart rates into a list. And then now the Internet of Things function that we wanted to put into our project is basically this email function right here. And basically, if you click this message will come up. It'll take you right to your email app, and this message will come out. It says this message has been sent because Heart Rate Monitor has detected an abnormal heart rate. Please follow up with patient. Heart rate history as it follows. And this is exactly the list that we were looking at the previous page. And then if I can make you, and then see, it just takes your doctor's email right there. So all you have to do is press send, and it'll send it right to your doctor. Let's open the app up again. Oh wait. Sorry, it's a bit slow. And then as you're collecting data and everything, you can also see all your heart rates right here on the graph. Right now I only have 7 in, but then the graph will grow and then scale to your normal heart rates. That way you can see when you've been exercising, when you haven't been exercising, and have everything right there for you. Okay, so that's pretty much the demo of the app. And that was my first time coding Android, and I had a lot of fun with it. So you guys should try it sometime. So now I'll show you our actual circuit design. I don't want to really move the phone, because then you guys will just get dizzy or whatever. But so this is our circuit design, and it was originally designed as a watch, and I'll show you guys how we can still use it though. 1 second, let me just plug in. Okay, there, now it's on. We have that green light right there as a heart rate sensor. And so what I did is I just I took a wristband, like one of those that like tennis players wear, you know. And then so what I did is I just took the heart rate sensor, just slip it right under here, and then I'll try to keep this stable as I raise it. But there you have it. That is our fitness watch right there. Very ergonomic design. Still on a breadboard. But yeah, that's pretty much it. If you have any questions, you can ask Josh or Francis. Thanks for watching.